Hi, this is Matisha from Jan Academy. So today I will tell about the basic rules that are applied to solve the questions in differentiation. It is sum rule, subtraction rule, product rule, division rule, logarithmic rule, and how to solve the implicit functions. So these are the things that I will explain today. So here I am beginning. See, if there are two functions in the addition or subtraction form, here are the two functions fx and gx. This is plus sign, this is minus. So if this is the given function and we have to differentiate it with respect to x, then how we will solve this? We will differentiate both the functions individually and the sign will remain as it is. If plus is given, then we will place plus as it at their position, and if minus is there, then we will keep minus at its position. Okay. So I am going to differentiate both the functions with respect to x. So individual differentiation of fx plus as it is or minus as it is, differentiation of second function. So this is the addition and subtraction rule. Second rule is how to solve a function in the product form if function is fx into gx form. Then how will solve this type of function? We will keep first function as it is. We have to differentiate it with respect to x. Okay, so we will keep first function as it is into differentiation of second function, then plus sign second function as it is into differentiation of first function. As plus sign is there, so we can differentiate any function first and we keep second function as it is. If we have taken first function, then we will keep second function as it is. If we have taken second function, then we will keep first function as it is. But both these terms should come. So first function as it is, differentiation of second function, plus second function as it is, differentiation of first function. This is the product rule. Now quotient rule. If two functions are in division form, then how will you solve that? If function is in the form of fx by gx, then how will differentiate with respect to x? With respect to x, we will give priority to numerator. We will differentiate numerator first. So second, denominator as it is, denominator function as it is, differentiation of numerator minus, not plus, second function as it is into differentiation of, numerator as it is, differentiation of second denominator, and denominator square or denominator square. Denominator as it is, differentiation of second function, numerator as it is, differentiation of denominator and upon denominator square. This is the division rule. We give priority to the differentiation of numerator. So we have kept the numerator. Numerator will be always first. In second term, we will differentiate the denominator. Now differentiation of logarithmic function. How will differentiate any logarithmic function? If a function is given as log of gx, then if we have to differentiate it with respect to x, we have to differentiate it. Then how will solve this? dy by dx will be 1 by gx into differentiation of gx individually. We treat gx as complicated part. So 1 by gx will directly come, and we will differentiate this gx individually in the product form. So this is the logarithmic differentiation of logarithmic function. Now differentiation of parametric function. Prior to implicit function, I would like to explain about the parametric form. Suppose y is a function sine theta and x is a function cos theta. Then how we will differentiate this function, this set of function? As we see that y is in the form of theta and x is also in the form of theta, so we will differentiate y. If we have to differentiate this set of function with respect to x, then we cannot solve it directly. We will differentiate y with respect to theta, and we will differentiate x also with respect to theta, and then we will replace dy by dx. We will solve the dy by dx as dy by d theta upon dx by d theta. So we will differentiate y with respect to theta. So dy by d theta will be sine theta. Differentiation of sine theta with respect to theta will be cos theta, and differentiation of x with respect to theta will be cos theta minus sine theta. So dy by d theta, dy by dx will be dy by d theta upon dx by d theta. So that will be cos theta upon minus sine theta minus cot theta will be the answer. So answer is in the form of theta, as it was given in the form of theta. So answer is also in the form of theta, and we have differentiated it with respect to x. Okay. Now I will explain about the implicit function. How to differentiate implicit function. To solve an implicit function, what is implicit function? First, I tell you what I am taking an example. This is an implicit function. We have seen the functions x involving x and y, but not directly x and y is in this form, in the product form. This is an implicit function. We have to differentiate it with respect to x. Then there are two methods to solve this function. First method I am explaining about. With respect to x, firstly you need to remind that we have to differentiate with respect to x. So we will forget that fx is this. Okay. Oh, sorry, fxy. Fxy, because it has two variables. But we will forget that there are two variables. We will keep y as it is. We forget about that y is a function. So y is a variable, another variable. We will differentiate it directly with respect to x, as we do. We know the product rule. We know all the rules for addition, subtraction, division, multiplication. Here division is not here. Addition is here, subtraction is here, and product is here. So we will directly apply the rules. We will differentiate every term, each of the three terms directly with respect to x. So forget about that. 3x square, 3y square. As it is not x, so a term dy by dx will come minus as it is. 3a will be constant. Then into x into y, we will apply product rule here. So differentiation of x is 1, y as it is, plus x as it is, differentiation of y equal to 0. So we will gather the term with dy by dx. Here 3 can be removed. So y square minus 3ax dy by dx and minus 3x square will be, minus x square will be here. It will go here. Yes. So dy by dx equal to minus x square upon y square minus 3ax. Let me check the answer. Um, 3ay. Yeah, I've forgotten this 3ay minus ay. So it will go here, ay. So ay will be here. So this is the answer. I have forgotten this ay term. So ay minus x square upon y square minus 3x. This will be the answer. Second method to solve this is again I am writing the function minus 3axy equal to 0. Now second method. With respect to x, how will differentiate it? So here another term, differential coefficient. Differential coefficient. Word will be used, coefficient. What is differential coefficient? Differential coefficient of this function. Differential coefficient of the function with respect to x, differential coefficient of the function with respect to y. So differential coefficient with respect to x is denoted by fx, and differential coefficient with respect to y is denoted by this fy. So differentiation will be dy by dx minus of fy, differential coefficient of the function with respect to y, upon differential coefficient of the function with respect to x. So in this form, and how we will find the differential coefficient, that I am explaining you. So this method is called partial differentiation. So in which we will use fx and fy. This is the method of partial differentiation in which I will solve this question. So fx will be, we have to find out fx and fy. Fx and fy. So differentiating this function with respect to x, how we will solve this? 3x square, then we will take y, we will forget y, we will treat y as a constant, minus 3a x y, and fy will be, when we will find out the fy, then we will forget about x, we will treat x as constant, then it will be 3y square minus 3axy. So answer will be dy by dx will be minus of fx fy upon fx. So we will place the value 3. I am removing. I will remove 3. I am taking 3 as common. Minus y square minus axy upon x square minus axy. So 3 and 3 will be cancelled. Minus axy, x square minus 3xy. Yes. So answer will be axy minus y square upon x square minus axy dy by dx. So previous method was very simple and this method is also good, but it takes time. So the basic thing is we have to understand the fx and fy. When we will differentiate the function with respect to, when we have to find out fx, then we will differentiate the function with respect to x, treating y as constant, and when we have to find out fy, then we will differentiate the function with respect to y, taking x as constant. So this is the answer. So in this lecture I have explained sufficient, and remaining part I will explain in the next lecture. Thank you.